All right, everybody, it's time to get started. Hello, everyone, and welcome to today's very special program. We are live with our paleontologists from the field in New Mexico who are right now doing the awesome and incredible work of looking for ancient life out there in the desert southwest of the United States. It's good to be with you. My name is Chris Smith, and I am your coordinator for current science programs here at the Museum of Natural Sciences. Welcome, everybody, to the Daily Planet Theater as well. If you're here, let's hear you. Give me a big clap and a woo. Excellent. I'm so excited to have folks here in the Daily Planet Theater and to be joined by so many people online who are eager to chat with our museum paleontologists about the work that they are doing. They are, like I said, in New Mexico, doing some pretty incredible work. Right now, this very moment, they are digging up, I think, dinosaurs, but probably even more kinds of incredible life. And to tell us all about it and give us an update from their field site is Eric Lund. Eric is the SECU Dino Lab Manager. That's part of the soon-to-be here Dueling Dinosaurs project. And he is in charge of the team right now in New Mexico. Eric, how's it going?
Hello. It's going great, Chris. Thanks for having us.
This looks like quite the scene. It looks like the team is pretty engaged in a project. Tell us how it's going in New Mexico.
Yeah, so up until a couple of days ago, it wasn't going that great. We sort of dug a really big hole, and we were not finding much. And then the last couple of days, we finally hit the pocket of bone, and we're starting to find more of this animal. What we're digging up is a horned dinosaur, so ceratopsian, so related to Triceratops. But what seems to be a much smaller relative of Triceratops in a group called the Centrosaurines. So those are the ones that you typically see with the really big nose horn and the smaller horns over the eyes. So this one is potentially something that's already known called Menipheceratops, but it could also be something really exciting and be brand new to science. But unfortunately, we just don't quite have enough of this animal yet to make that comparison, and that's why we're out here digging this guy up.
That's incredible. That sounds very exciting. Give us a sense of where you are in the world and where you're standing, what's going on around you right now.
Yep, so we're out here in northwest New Mexico in a formation called the Menifee. This represents a package of time that's about 83 to 80 million years ago. During this time, North America was divided into two land masses, the western landmass called Laramidia and the eastern landmass where you all are in Raleigh called Appalachia. And here in the west, we had big river systems flowing off big mountains being built to the west and into this seaway, and all these rocks surrounding me were deposited by these big rivers. And right directly behind me is our quarry where the crew is working. And so they're painstakingly going through every layer of mudstone and sandstone to try to uncover the fossils of this horned dinosaur.
That leads me to an interesting question. How in the world did you even begin to find what you said is a small dinosaur in all of that desert?
Yep, so the way we find bones out here is we can't use any ground penetrating radar or anything like that. It just doesn't work. We've got to actually see the bones eroding out of the rock. So if you can see behind me a little bit, this is what's called badland type topography. So really high relief, a lot of erosion, and that erosion is going through these layers and causing these bones to erode out. And when we find bones eroded out on the surface, then we try to find the layer, the horizon that those bones are coming from. And once we find that horizon, then we start digging in. So I believe this particular site was found by Dr. Zano as we were out here prospecting, looking for new sites, and she saw a little bit of bone eroding out. And just like I said, started to dig in, and we started finding more and more bone. And at first, we found quite a bit of bone, and that's what brought us back this year. But like I said, we dug in, and we only found 4 bones right away. And then after that, we had a drought of a couple days with nothing, and we were starting to get pretty down. But we kept pushing into the rock, and we started finding more and more bone, and so we're really excited.
So as you're finding these dinosaur bones, it sounds like they're just kind of scattered into the hillside. but from like movies and fiction and entertainment stuff, I always think of dinosaur skeletons. They're just like laid out. Here's one big skeleton, all the bones are in a row. It doesn't sound like that's the case.
That's not the case with this particular specimen. We do have a lot of the bone, but they're called disarticulated, so they're not in life position. So very, very rarely do you find a dinosaur that's beautifully laid out and articulated like you see in Jurassic Park, or soon to be with our new dueling dinosaurs. Those are all together, all the bones are in life position. But this particular specimen, all the bones are jumbled up and at various orientations. Some are laying flat, some are vertical, and they're all sort of jumbled. We've got postcranial bones, so bones from the body mixed with what appears to be some of the bones closer to the head. And unfortunately, we don't have any skull bones yet, but hopefully as we get into this hill, we'll start finding those.
Are skull bones more important to find, more exciting to find? Are they better for trying to identify the dinosaurs or doing the research later?
Yep, so for horned dinosaurs in particular, skull bones, and I guess with most dinosaur groups, there are some exceptions, but if you find the skull bones, those help to diagnose this animal. So we're excited to find those. Plus, it's really neat to find the head of these things.
It must be really exciting to just start shoveling into the hillside there, and then all of a sudden seeing and finding more and more bone. Tell us about the process of not just discovery, but of actually getting the bones out of the hillside. I see the team behind you using like picks and brushes and scrapers. It looks like pretty interesting but tough work.
Yeah, it is. So once we open a quarry and we start out with bigger tools like picks and shovels, and we work our way down towards that bone layer. Then once we actually get to the bone layer, then we go with smaller tools. So sometimes small awls, sometimes even dental picks and smaller brushes. And we painstakingly chip away the bone, and we try to create flat surfaces and work our way down. We try not to dig in or dig tunnels in, so that once we start uncovering the bone, we can see it right away. And then once we have found a bone, then we'll trench all the way around it. So now your bone is sitting on a pedestal of rock. And once we get it on that pedestal, then we start to undercut that pedestal. So then your bone's sitting on basically a mushroom of rock. Then we got to protect it, right? These bones are millions of years old. In this case, 83 to 80 million years old. And if we just took them out of the ground, they'd fall apart. So we got to protect them. And in some cases, we use what's called a gypsona. It's basically a plaster impregnated terry cloth that we can put on. In other cases, for bigger bones, we got to use plaster and burlap. So we protect the bone with a layer of separator, like paper towel, and then we start layering up the plaster and burlap and create that hard shell or that field jacket. And you might be able to see one behind me here. Emmy there in the white shirt, that's a field jacket that contains the radius or one of the forearm bones of this animal. So that's just layers of plaster and burlap around there. And then once we get enough layers to protect that bone, then we break it off that pedestal and flip it over, and we'll clear down some of that rock so we can see the bone from the other side and make that jacket lighter. And then we'll put more layers of plaster and burlap on. And in this case, this jacket's pretty small. It's only going to weigh about 25, 30 pounds. We'll throw it in a backpack and we'll carry it out. If the jackets are much larger, in the order of hundreds of pounds, then we either got to put it on a stretcher board and team carry it out, or if they're even bigger than that, then we put them in a helicopter net and we fly them out.
That sounds like so much fun.
Oh, it is. It's great fun to be out here.
Sounds awesome. I'll let everybody, if you're watching live on our YouTube live stream, you can drop questions for Eric in the chat. I've got that pulled up, and I'll ask your questions into the program. And if you've joined me here in the Daily Planet Theater and you have questions for Eric, you can yell them at me, and I'll use the microphone and talk to Eric. But you can also come over and join me on screen and on camera and use the microphone and ask Eric your questions. So if you've got questions, just wave at me, let me know, and then you can come right over. There's a question over there. If you'd like, you can come get on camera and chat with Eric. Step right up. While they're coming over, Eric, what is the weather like today? We saw sandstorms in a video that you sent yesterday, but today doesn't look too awful.
Oh, today is absolutely beautiful. A couple days ago, it was boiling hot, and then we got these sandstorms that came in that sort of exfoliated all of our skin. But today it's a little bit overcast and really, really nice. So perfect day to be out here in the desert.
Excellent. What's your question?
Hi, I was just wondering if you can tell based off the bones that you have so far, if it's a carnivore or a herbivore, or if you have to get the skull to figure that out.
Nope, we know that it's a plant eater. So based off of the bones that we do have, which is most, so we got some arm bones and some leg bones, we can tell that it belongs to the group ceratopsians or horned dinosaurs, and we know that those ate plants. So definitely a plant eater. We have found some isolated teeth belonging to a crocodile in here, but that's all we found, or just some isolated teeth. And no meat-eating dinosaur teeth showing up so far in this particular quarry, but definitely a plant eater. Yeah.
Awesome. Excellent question. You've got one too. Come right on over here.
What kind of degree do you have?
So I have an undergrad in geology, master's in geology, and I'm about finished with a PhD in biology. So those are the degrees that I have. Behind me, I've got Chinzo, who's a doctor, also in biology. I've got a couple master's students who are getting their degrees in biology. So you can get different degrees to be able to do this.
That is cool. That is cool. I always am impressed with paleontologists because, like Eric, even just talking to you now, you were talking about the different types of rock and soil that you have to dig through, but then also describing the anatomy of the dinosaurs. So it's like you're a rock scientist and you're an anatomist and a physiologist and a biologist and a paleobiologist. Like, how do you wrap all of that stuff up into one package?
Well, kind of do a lot of reading, and you get to know a lot of different things. But luckily, this paleontology is very interdisciplinary, and so we don't have to know all the things. We have colleagues who know things, and so you really draw upon that pool of knowledge and come together and collaborate on all these projects. So if there's some aspect of a project you don't know, you'll have a colleague that hopefully knows that and helps bolster the scientific value of what you're doing.
Awesome stuff. Hi, oh my gosh, you've got a cool dinosaur shirt on too. What's your question?
How long did they dig at a digging work site?
So we found this, that's a great question. So we found this particular quarry a couple of years ago. So we've been digging it every year since then. But this particular time right now, we've only been out here about 2 weeks. We got a few more days before we move camp up into Utah.
So you were there for a few weeks last summer, a few weeks the summer before that.
Yep.
And now you've got a few more days there, and then it's on to the next one.
Yep, then it's on to the next one.
Now, is that enough time to, say, recover all of the bone that you find, or will you have to, come back next summer to try to get more dinosaurs?
Well, it was looking like that this quarry was gonna tap out and we'd find nothing, like I said. But now that we are starting to find more bones, our time here is very finite, and we're not going to be able to collect everything. We will collect what we've uncovered so far, but my guess is we'll definitely have to come back next year and reopen this quarry, dig another big hole, get down to the bones. So we'll be back.
They'll be back. Got another question for you.
Hi, so how does the weather affect how you're able to preserve the bones?
Yeah, great question. So wind, no problem. We can deal with that. The only problem that we really run into if it's raining or if it's snowing. When these rocks get wet, they basically turn into really slick mud, which makes it really hard for us to work. So any type of moisture is no good for us. And so we really prefer nice dry days. Sandstorms we can deal with. We can sort of put buffs on and goggles and cover up and deal with those. But any sort of precipitation is no good.
And then you also said that the ground penetrating radar doesn't work where you are. Why?
Yep. So another great question. So ground penetrating radar doesn't work because those sort of technologies work off of density differences. And because these fossils are found in the rocks that they were preserved in, the density contrast between those tends to be very, very small. So the signal you get back from those technologies just isn't oftentimes very good. But perhaps that's technology as we go through time and it gets better and improved, those technologies might work as they get more sensitive. But that's the reason is those density contrasts just aren't good enough. So we can't use that.
Excellent stuff. Some questions that are coming in for you from the web. How long does a typical expedition last? This one you've been there, you'll be there for 2.5, 3 weeks. Is that normal?
So it's quite variable. Altogether, our entire time out here in the Western United States is going to be about 13 weeks. So that's for our North American crew. We also have a crew that's going to Mongolia mid-July, and they'll be out there for 6 weeks. So it's a long way to go for just a couple weeks. So they'll be out there for 6 weeks. But I've also been out for months at a time. So I've done back-to-back field seasons in Tanzania and Madagascar, where it was 1 month in Tanzania and then 1 month in Madagascar. So it's really variable on the projects you get going, what you're doing. So they can run anywhere from a couple weeks to a couple months.
Another viewer wants to know if you had to guess what ceratopsid or centrosaurid are you working on right now?
Yeah, great question. So like I said earlier, this could be the only known ceratopsin from this formation called Menipheceratops. It was named a couple years ago, but it also could be new. But we just haven't recovered enough bones from this animal to compare it to the material that's been ascribed to Menipheceratops. And hopefully we'll get, as we get more and more bones, we'll be able to do that. Figure out if this animal is Menipheceratops or if it's something new.
You told us that you have forthcoming degrees in geology and in biology. Would those be the two things that you think a young person who wants to become a paleontologist should study? Are those the two most important things? How else can somebody get involved?
Yep. So I would say those are good degrees, biology and geology, to be able to understand the rocks you're looking at, but also to be able to understand animals. But like I said before, paleontology is very, very interdisciplinary. So I would say find the thing that you like to do and do that, and then find a way to connect that thing you like to do to dinosaurs or fossil plants or other fossil animals like crocodiles or even birds. It doesn't just have to be dinosaurs. Paleontology is made up of a whole bunch of different things. Trace fossils, so the ichnology, the study of trace fossils. Palynology, the study of fossil spores. Vertebrate paleontology, so dinosaurs, everything with a skeleton. Invertebrate paleontology, all the soft body things get preserved. There's many, many different aspects of paleontology. So find that thing that you like to do that, and then turn it into paleontology.
One of our viewers wants to know how far you had to hike in to get to this site.
Yep. So our camp, that's a great question. So our commute every day so far has been just about a mile. So looking out across the valley behind the camera here, I can see our camp. It's about a mile away. Some of our quarries that we have in Utah, the camp is really, really a short distance from the quarry, and others you got to hike in. But in this particular case, we're about a mile away.
Doesn't sound too bad.
No, not too bad. It's a beautiful, beautiful commute in the morning.
So if somebody wanted to be able to go and excavate dinosaurs, or if they wanted to work on the dinosaur bones after they've been excavated and are back here in Raleigh at the museum, are there ways for them to do that?
Yeah, so we have a volunteer program at the museum. They would just need to get in contact with us and start out as a volunteer, get to know what tools we use in the lab, get to get their eye on some fossils, get that training. And then if they're really still excited after that, then they can, there's potential for them to come out in the field with us and work alongside of us, digging up, whatever it is we're digging up at the time.
Excellent stuff. Sure.
Private property or public property? Can
Oh.
anybody just go to that big site?
The question from the audience here in the theater is this public land that you're on, or is it private property? Could somebody else come up and dig up your dinosaur bones?
Yeah, great question. So we work on public lands. This particular plot right now is New Mexico state land. And we have to go through a pretty rigorous permitting process to be out here working. But with regards to just anybody coming out here and finding this site, it's very, very remote country. And in fact, if you didn't know exactly where this was, it'd be a really tall order to find it, because we are off the beaten trail for sure. And most of our quarries are. I've never had any problem with people messing with sites, coming back and seeing any vandalism like that. But so we do have to go through a permitting process to be out here to work. And vertebrate fossils are protected by law, so you can't just come out here and collect. There are differences with private land, so private landowners in this country, if they find fossils, they can do with it what they want. But we're here on public land.
Excellent stuff. Can you take a moment? One of our viewers wants to know and introduce the team that you've got there with us.
Oh, absolutely. So behind me, I've got Dr. Chinzorik. He's got the gray hat on. Then next to him is a doctoral student, Josh Hedge. Next to him is master's student, Emmy Bender. And then on the other side in the aqua shirt there, that's Kyle Obucheski, brand new master's student in the Xano lab. So that's who I got out with me here today.
This is great. Tell Emmy that her Aunt Nan says hi.
Emmy, your Aunt Nan says hi.
That's awesome. Okay, question from the room. Ooh, a question that came in online too. What happens if you accidentally break one of the fossils?
Yeah, it happens all the time. So we got various ways to sort of mitigate that. Again, going slowly so that once we get to the bone and uncover it, we don't hit it. But occasionally, as you're chipping away, you'll accidentally hit the bone and break it. But we use a stuff called B72. It's a consolidant, basically a plastic we dissolve in a solvent, which we put on the bone to help hold it together. So if we break the bone, it's not too bad. We can sort of mitigate that, but it happens often.
I'm glad they got that one figured out. You know how to take good care of the fossils. Other questions from the room? Just wave at me. Okay, I see one across the way. Yeah, come on over. You can join us on the live stream. Oh, and your question, come on over. Step right up. Tell us what your question was. Oh, okay. So down here inside the Daily Planet Theater is the question here. I don't have any fossils of T-Rex here inside the theater with me right now. There's a couple of fossils down there working in the digital media booth, but we don't have to say much about it. Oh, at least one person laughed at that joke. Thank you. But we do have fossils of lots of different dinosaurs, including, I think, some T-Rex, all throughout the museum, including on the 3rd floor of this building. Just one floor up is the Paleontology Research Lab that's run by Dr. Lindsay Zano. And you can't go down into the theater, but you can go upstairs and actually see the dinosaurs that our team is working on right now up on the 3rd floor. All right, let's get another question. Come on over. Say hi to Eric.
Hello. So I was wondering, you said that the fossils aren't found in life position in this case. Why? Like, so the animal, like the dinosaur dies. So why is it not in life position? Like, what makes it change where it is?
Yep, great question. So we know based off of the rocks that surround this fossil that this was some type of pond, and we know that this pond um, was associated with a floodplain. So all these rocks were deposited by a fluvial system or a river system, and so these bones being disarticulated, not in life position, we know they were transported a little bit. So the animal died somewhere, probably decayed, and then through those processes of the river flowing, got transported to this little catchment basin, and then got deposited and covered with the mud, and stayed that way until they started to erode out, and Dr. Zano found them.
Excellent stuff. A question from the chat for you. What other genre of animals have you found in the area you're at? You mentioned crocodile teeth, I think.
Yep. So we got some croc teeth. So we know there was croc. As we're hiking around these rocks, we find pieces of turtle shell. So there were turtles here as well. Just over the hill behind me, a very short distance. Last year, we collected parts of a really big duck-billed dinosaur or a hadrosaur. And then last year, again, around the corner, short distance from here, we found an armored dinosaur, an ankylosaur, at least parts of it. And so we got to go back and check that one out for sure. But we also know that there's meat-eating dinosaurs here. We found toe bones of them. We found other parts of meat-eating dinosaur skeletons. So this whole area was covered with all sorts of different life.
Awesome.
So you talked about the crocodiles and all the other kind of animals that you found in the area. So what does that mean about like the environment that the dinosaurs lived in, or can you like make any assumptions about that?
Yeah, so we know that this, so we also get fossil plants preserved in these rocks. So it was a carnivorous forest. So we get a lot of pieces of pine trees and other gymnosperms. Like cycads, we get palm fronds. So we know it was a bit forested. We get a lot of plant material. We do have quite a few petrified logs around this area. And we know from these rocks that sort of this area was fluvial, so river systems. So there is some sort of carbonaceous pond deposits. So we had ponds. We had river channels because we get big sands. We have floodplains and a bit of forest. So looking at all the rocks and all the different fossils and other animals around here, we know we can sort of start piecing together that story of what it was like 83 million years ago here in New Mexico.
83 million years ago. It's wild to hear you describe this environment, as in like the place you're standing and sitting and working right now was lush green forest. There was water everywhere, and now it's brown with a little bit of green.
That's right. Yep. Now it's a desert.
Incredible stuff. So another viewer wants to know if you've encountered any wildlife on your digs. You're out there in the nature.
Yeah. Oh, we have. So we got a bunch of crows that hang out around camp. There's also a herd of wild horses that are in around here. We get to see them every once in a while. Here in the quarry, yesterday we saw a scorpion. So as I was digging through the rock, a scorpion popped out. And so we get to see all sorts of different things. There's evidence of deer around here. We find some shed antlers. But yeah, so the things that we see mostly are the horses, lots of different birds, lots of different squamates or lizards hanging out around here. So yeah, it's a beautiful place to hang out with the wildlife.
Sounds awesome. All right, I'm looking around. It looks like we're just about out of time with you, Eric. I don't want to keep you for too long. I want to make sure there's plenty of time to get those dinosaurs out of the ground and back to Raleigh. So let me, I'm going to throw one more question your way from the chat. What made you want to become a paleontologist? What's your favorite part?
Yep. So I've wanted to be a paleontologist ever since I was 3 years old. And sort of just never grew up. Way back when, ages ago, my grandparents took me to Dinosaur National Monument, where I saw them working on dinosaur bones, and for whatever it was, that's what I wanted to do. And so here I am in the middle of New Mexico digging up a dinosaur. So I've always just been fascinated with dinosaurs and ancient life, and now I get to do it as a job. So it's pretty great.
And what's your favorite part of the job?
My favorite part of the job, besides being out here in this beautiful landscape, is that discovery. So being able to see a bone that hasn't been exposed for millions of years is super exciting. And just the exploration. When we're prospecting or out looking for new sites, you never know what you're going to find. So you could go one way and find nothing, but turn the other way and find yourself a dinosaur. So yeah, it's that sense of discovery. That's my favorite.
And that, I think, is an awesome place to leave it. Eric, take care out there. Thank you for joining us today and taking time out of your busy dinosaur digging time.
Yeah, thanks for having us.
All right, be safe out there, and be careful, Emmy, hauling those big dinosaur bones around. Be careful.
All right. Say bye, everybody.
All right. Thanks for tuning in, everybody. Thanks, everyone, for joining us here in the Daily Planet Theater in downtown Raleigh. What an awesome program. What an incredible show. We will actually be checking in again with our paleontology team in July. On July 7th will be our next edition of this program. So go ahead, mark your calendars. Check out naturalsciences.org for more information and resources on programs like this one and more. And hey, if you're interested in volunteering here at the museum, like we talked about earlier, head to naturalsciences.org and you can find all of the information in order to get involved in what we're doing here at the museum, like paleontology, but also so much more. Until next time, everybody, be well, be kind, stay safe out there, and we'll see you again real soon. Bye, everybody.